Speech is a more efficient means of communication when compared to text writing. And one statistic which speaks in favor is that we can speak at the rate of 150 words a minute, as opposed to an average person who can type at a paltry 40 words a minute. Now, naturally, this has encouraged a lot of people to bring this efficiency to the homes in the form of voice assistants. And today, the purpose of my next 10 minutes is not to talk about that and the future of those technologies, but to dive deeper into how some of these transformations, these technologies can transform the workplace. So that's what we'll be focusing on. While these technologies have come very far, they still have a very long way to go. And despite speech being more efficient, text has its own advantages. One of them being that it canonicalizes a whole bunch of accents into one common form. Also, it's more conducive for representation on machines. It's better processed on machines and can be stored for easier retrieval. Example is search. Now, this has basically led a lot of companies to invest in this area, like the whole transcription. Even before these systems were mature, a lot of an example like this has been used before. An example is the court systems. Courts have these reporters whose job is to listen through the proceedings and transcribe them word to word. And why is this important? It's because this makes it very efficient for lawyers to cross-reference cases and make their arguments and circumvent a long trial. This has been recognized well before these technologies were mature, and so it makes sense that there were lots of research efforts to automate this process and bring technology into this picture, and that's essentially what happened. Now, if I were to work on this technology, and developing these technologies, one way to do that is to work backwards, right? What is language composed of? Natural language is composed of words, and words are the smallest units of language which make semantic sense. And the process of starting from audio signals and working backwards towards these words is called transcription. And this is an important and difficult problem in itself. And people have worked on this for a very long time. This journey is a long, arduous one, starting from being able to recognize digits. Actually, we are proud of being able to recognize 9 digits just by the creator of the system, all the way up to the current capabilities of voice assistants that a lot of you would be familiar with. Now, this journey is still one part of the bigger journey, right? So these text transformation systems of today are able to they're developed to such an extent that for certain language accent pairs, we can call this problem solved. For example, when the key part here is language accent, right? This can be called solved for certain languages like US English. And what about the rest? There is active work being done on the remaining accents, remaining set of languages. Now, what do I mean when I say solved? That there is a machine which can recognize this at human parity. The best that a human can do, there are machines which can do at the same level on certain data sets. That's what solved means here. Now, what next? What next for these kind of systems? What's next is that we need to work forward in terms of being able to make sense of what these words mean, right? When put together at arbitrary levels of complexity. What do sentences mean? What do these sentences put into paragraphs mean? What do these term-based conversations mean? And that's the next step. And that's essentially where a lot of work is and engineering efforts are being devoted. And that is what my company does, Strings.ai. So we are a startup in this space called conversational intelligence. One way to describe conversational intelligence is you start with audio signals like voice, speech, and try to derive insights and functions based on that. And why is this an important problem? It's because conversations are an integral part of many workplaces. Workplaces are filled with conversations, both internal and external. We need to have conversations to try and sell a product, which is sales. You need to have conversations when customers reach back, when they have problems with your product. You need to have internal conversations, meetings, facilitate meetings to get things done, to get work done. Now, a lot of these conversations are recorded. Some of these conversations are recorded, a lot of them aren't. And even among the ones that are recorded, there is very little automation being applied to these conversations. And that is essentially where we come in. Now, I know that this is very hard to understand without an example, so that's exactly what I'm going to do. One example of this is, let's say you're in a call center setting. So there are customer service agents who are dealing with calls, and quality assurance is an important part of this process to make sure your agents are delivering the right quality of service. Now, how this is done is typically you sample a small set of calls and you have people listen to these calls and make sure the call is going as expected. And this is a very time consuming process. As an example, if you want to audit a 3-minute call, it takes anywhere between 6 to 10 minutes to audit this call. We believe that if you were to be able to get a machine to do this, you can do it in a fraction of the time. And you don't have to deal with sampling of any of this. Another example of this is I can apply this to the sales domain. Now, if I were to ask you, what makes a good sales agent? One who talks more than the customer or one who talks less than the customer? So my intuition when I was asked this was that as a persuasive sales agent would likely be talking more than the customer, trying to make his point, trying to sell everything that has to say about the company. But that doesn't, the statistics don't seem to say so. A good sales agent is barely talking 50% of the time in a sales call. And these kinds of insights are counterintuitive and can only be delivered through more accurate statistics. Another example of this is, let's say, if I ask you, is it right to bring up a competitor mention when you're in the sales conversation? Is it better to bring up a competitor early in the process or late in the process in the sales? My intuition would have been to bring a competitor later in the conversation or even never, because I don't want any distractions away from my product. But it turns out that there is a stronger correlation. There's a 50% chance of you making a sale if you're upfront about your competitors and why you're better or how you compare to your competitors. And these kind of insights can only be delivered and gathered through more better automated means of processing your data. And a more futuristic example of how voice technologies, and when I say voice technology, not just transcription, but technologies which can understand the whole conversation, can help in bridging the gap between marketing and products and sales, right? Product teams are constantly trying to engage with their customers to build the right thing that their customers need, whereas sales teams are just focused on selling what they already have, right? Now, 80% of sales conversations don't go anywhere. But the reason why those conversations fail is never communicated back to product teams. What if there is a way to bridge this? As an example, let's say you're a payments processing company and you're the chief complaint that the common aspect of all your failed calls is that the payments take too long to process. As in, I make a payment today, it only gets delivered 48 hours from now. And if I were able to deliver this kind of insight to the product team, and this is something which is not only good for them to know, but is something more actionable for them. And these are some of the things that and examples of why conversational intelligence can transform workplaces. So where are we as things in this journey? So what we're able to do today is that we're able to do call adherence. For example, you tell me this is a call script I expect my agents to follow. I can tell you whether they're actually doing that. And why is this a hard problem? Because call script is just one script. It can be delivered in many different ways, many different paraphrases, and accurately identifying all of these and tracking the call is something which is not very easy for a machine to do. And another thing that we're able to do is we're able to provide lead like quality or health of the call. A machine which is able to listen to the call through subsequent calls that you make on the same sale and tell you how the sale is progressing based on how engaged the customer was, what kind of questions were asked, what kind of was pricing discussed, what competitors discussed, and things like that. And another example of this is lead qualification. That is, these are things that we're already able to do. And in the near future, what we expect to do is for customer service, Agents have a very short life cycle. Customer service agents, they work in a company for less than 12 months, and they spend more than 30% of their time trying to ramp up. And if you can make their learning on the go, as in they're learning as part of the job, as in they don't need as much time to ramp up in the form of they have knowledge banks, and these knowledge banks help them answer the calls, and they don't have to really memorize these and get spend as much time getting familiarizing themselves with this. These are some of the things we expect to solve in the longer term. So ultimately, over generations, these kind of technologies have transformed humanity by enabling them to free up their workforce, primarily to move on to harder problems. And an example of that is the ENIAC, which is the world's first electronic programmable computer. This was developed by the US Army for ballistics research. The ENIAC could do in 30 seconds what it took a human 20 hours to do. And ultimately, the math is that an hour of the computer's time was equivalent to 2,400 hours of a person's time. And in this customer service scenario, about 1 trillion words are spoken every year, actually, every day. And can you think machines can help?